Now that we are in the era of Tesla, as it were, with electrification underway for transportation and a major rout of the oil industry looming, there are still poor understanding of the concepts going around when it comes to electric cars versus fossil fuel cars. Lots of doubt, especially propagated by analysts, who sometimes at least are paid to follow a certain narrative. But a little thought experiment can provide some much needed clarity. That is something that Wall Street tend to be in short supply of. Let us set the record straight here and now. We're going to show just how embarrassingly inappropriate the whole fossil fuel system is, no exceptions. First, let's consider how energy is procured. In the case of fossil fuels, the oil must be drilled, often from beneath the ocean or deep under deserts in remote areas. This, along with the pumping of crude oil to the surface, requires energy. Then it gets refined and processed, more energy. After that, it gets loaded in huge tankers and shipped across the globe. Then it is collected by road-going trucks at the port depot and distributed via road to your local gas stations, where it is stored in tanks underground, ready to be filled into your car. All that energy to transport those heavy gallons of fuel before it ever gets used. And when it does finally get burned in the cylinders of your engine, the fumes get dumped out the back and into the atmosphere. Safe in the short term at least, as you speed ahead down the road. So what happens with the transport of electricity by comparison? With renewable production like with wind generation or solar panels, it will likely get made locally. But even if it is made thousands of miles away, it could still get transported to you in about a second at no cost of transport. And from anywhere on the globe, like magic. No shipping, no large containers on the move, no truck drivers employed, no wear and tear, nothing. Electrons travel instantly to the destination storage. So it's easy to see how no physical fuel can ever compete with that. Now, about the actual car itself. Okay, take your conventional gasoline car, petrol or diesel, new or old, maybe your efficient little 1 litre that you just drove out of the showroom as new, or that SUV guzzler, the high powered V8 sports car maybe, the beaten up truck, or even Grandad's wonderful Studebaker. All of these will serve the same for our purpose. So start the engine and go for a drive down the highway to get to normal operational temperature. Now pull over to the side of the road and turn it off. Open the hood over the engine. What's the first thing you notice? The answer, as everybody knows, is a big blast of heat into your face. That is because typically 80% of all the fuel you paid for at the filling station gets wasted in the form of heat. And not just the recent fill of gas you got, all the fuel you ever put in your car. Consistently 80 to 90% of it gone. Theoretically this figure is a little over 70%, but in practice over 80% of it is what is actually wasted. That is how grossly inefficient the internal combustion engine is. And what's more, we've been doing this now for a century. The ICE, or internal combustion engine, is a heat machine, a glorified water boiler that is also harnessed to do other work, mainly that of transport. We all engage in this situation of mass ridicule at the behest of the oil industry. Driving everywhere, our cars are still a tool of liberation, but never has there been a device like the ICE, so widely used for so long and so unsuitable for the task. Now let's consider an electric car, and we mean an all-electric car. For example, the Nissan Leaf, or maybe you know someone who has converted their car recently, but we do not mean hybrids like the Toyota Prius. This has an engine which charges the batteries. If you have to go to a gas station, it's not an electric car. When we give the EV the same test, we find hardly any heat generated because electric motors are the complete opposite to ICEs in this regard. They are 85 to 90% efficient, meaning most of the charge you put into your batteries actually gets used to drive the wheels. In fact, most of the time, you can probably put your hand on the motor in an EV without burning yourself. Try that with a gasoline car. In an electric car, when you turn on the air conditioning or the lights, the exact amount of energy required is released from the battery pack with great efficiency. With gasoline, even energy for the lights comes indirectly from the fuel tank. Traditionally, lights use from 10 to 20 amps. As part of our energy wasting culture, we never count such a cost. Only now, with the EV being developed, are we finally making LED type bulbs, light emitting diodes. In the world of electrons, we are looking to save power wherever we can. The earlier lithium state-of-the-art batteries around 2010 only allowed a range of about 100 miles per charge, the exception being a Tesla model. You remember your first mobile phones and how cell phones so quickly evolved after their introduction. As with any new technology, early adopters must harbour a compromise. But in just a few years, the day of the 2 to 300 mile EV has more or less arrived. Occasionally in these debates, you'll hear skeptics trying to ridicule EVs, but there are actually no intellectual arguments in favour of the internal combustion engine. And there never were, except to say that they have served as a temporary stepping stone that has been employed for far too long. You'll hear the critics say that charging an electric car at home simply means delegating the fossil burning to a power plant elsewhere. But even that is a misrepresentation, as these plants are nowhere near as inefficient as the explosive cylinders in an ICE. On top of that, the coal industry has been dealt a heavy blow in recent times due to the increase in solar. And of course, with charging at home, you have the very real prospect that someday soon you will install solar panels, wind generators and a charging station, thereby truly eliminating fossil fuel and the oil companies. Not just clean transport, but ultimately free transport. Perhaps unconsciously, the endgame for oil has already begun. It's easy to find the masses scoffing at such a notion. We've already seen this happen in other fields, and one of them added a very recent chapter to the Industrial Revolution. Remember having film in your camera? No. If you are very young or very new to photography, you won't. Yet only 10 years ago, amidst promising new digital camera technology, there were film industry giants who were taking down the digital camera and saying how it was a long way off matching film for resolution. Indeed, in 1999, it was something of an amusement to play around with the first digital cameras, 1.3 megapixel. They were very clearly limited, and no replacement for the professional with his SLR 35mm. The feeling was that it would take 20 megapixel resolution to equal the mighty film, a tall order at the time, and indeed impossible. But civilization moves forward on the wheels of compromise. And while technically that was true about the resolution, in practice, bringing less than half that sophistication to market would be all that was needed to drive a nail in the coffin of film. Soon after, Canon came out with the amazing 10D digital SLR at just 6.4 megapixel resolution. The floodgates opened and everybody on the planet wanted a digital camera. Yet the people who were famously in denial were those in the Kodak Corporation. It seems they were ignorant of Moore's law, surely the stamp and seal of our time. Issued in 1962, it states that the density of electronic components in a device will double every 18 months or so. This evolution has been visible everywhere to everyone in the modern world, but not apparently to Eastman Kodak. With their salaries and benefits and specialized careers, they did not see it coming. Denial ain't just a river in Egypt. But the public knew what they wanted, and they made the decision once the scene was set and the possibility had been rolled out. By early 2009, I was able to buy a 12 megapixel camera which can slip inside a cigarette box. Its performance is so staggering, and yet it is nowhere near the professional end today. Oh, and you can still buy film if you wish, but wait till you see how hard it is to find. Yet the driving forces behind that development were bubbling away since the 1970s when NASA developed digital cameras for their spacecraft. The Voyager spacecraft, launched in 1977, was an astonishing success, and it was easy to see that humanity might be inspired to have some of this marvellous technology in every hip pocket. But it did take time, and the march to progress had to grind on painfully. By the early 90s, the Charge Coupled Device, CCDs, were being used by amateur astrophotographers. This field served as a kind of testbed, an area where passionate people would spend money on expensive devices to get their image from the night sky. It was actually through this interest that I gradually came into photography. That was in 1998. And even then, I remember seeing a news item on the TV about some university that had developed a huge CCD which they claimed could in theory be used in commercial cameras one day and end the need for film. That day came very soon after, and the rest is history. Film is dead, just like old Marley and Dickens, dead as a doornail. There is a realization setting in that the oil companies are bad, or at least less than good. Into the public mind comes the notion that it could be perhaps amusing to have an alternative type of car for some of our transport, or even all of it. The existence of hybrid cars for years have helped this awakening. By the way, as hybrid cars are actually electric cars with very small traction batteries and engines to intermittently top up the battery, they could have been made in the 1950s, as there is really no special requirement. It would have greatly saved on fuel consumption and pollution worldwide. But car manufacturers never gave it a moment's thought. Hybrids were not a thing until Toyota, to their credit, introduced the Prius in 2000. But things have moved on since then. Now, with companies like Tesla being followed by VW and the South Koreans and others, pressure is being applied to legacy car makers to go electric or get bulldozed. A lot of these companies have relied too heavily and for too long on making fossil fuel vehicles, not investing in battery making technology, and frankly, now finding themselves disenfranchised from this stuff, sterile and in a panic. But inevitably, the consumer will shed no tears. Depending on who you ask, the floodgates for electric cars are due to open wide between 2022 and maybe 2025. What happens at that very moment? At that moment, the average price of electric cars will be as low or as lower than their fossil fuel counterparts. As it will no longer make sense, the sales of gasoline or diesel cars are expected to drop away. From that instant, every idiot will want electric and nobody will want combustion engine. In part because these cars will lose their value rapidly. So you might see people holding off before buying a new car, a kind of Osborne effect. This could see an increase in the motor repair sector. But as EVs become more prevalent, car service along with the oil industry will surely fade. With few moving parts and with little or no cooling issue, the electric car will have no servicing, no oil change, no filters, no spark plugs or injectors, no fan belts or timing belts. This is why the likes of Tesla can sell direct to the consumer. In fact, with the AC motor in an EV, you have regenerative braking, which means that the circuit gets reversed when you brake, thereby pulling some charge from the moving wheels and back into the batteries. So you actually have an additional braking system. As a consequence, the traditional friction brakes though present, tend to be used far less and pad replacement less common. Another really dramatic benefit of the electric motor is that it produces maximum torque at 0 revs. This means that the car needs no gearbox, unlike the poor old combustion engine, which needs to get its revs up before giving you decent power. An electric car can sit in heavy traffic, using no power since nothing is happening, instead of having to tick over, getting hot and wasting more energy. With all the heat and sunshine, I am ever mindful of the immense power of the sun, wasted every day while we pay for power. Being almost 1,000,000 miles in diameter, it is the biggest nuclear reactor by far we are ever going to have. It is estimated that only something like 5% of the Sahara Desert could, through solar power, provide all the energy needs of the world. Not even all the oil wells on Earth can come anywhere close to what the sun can do. We should not be surprised. Without its presence, we would freeze over in darkness. Tapping into only a tiny fraction of what the sun has to offer would change our world forever. Of course, to do so on the scale required would involve the proliferation of solar panels combined with large, ground-based battery storage. Tesla is already making great strides in this sector. To those who think it will never happen, look what happened 100 years ago with the oil industry. In terms of solar panels, 1 square meter area captures in theory about 1 kilowatt of power, though the efficiency of solar panels might typically be 20% of that. An electric kettle uses about 2 kilowatts of power, so a kilowatt is heavy power. Even if all your home installations produce 1/4 of that, it will reduce your electricity bill considerably. I use approximately 4 kilowatt hours of electricity in a 24-hour period in my house. That's like a kettle plugged in for 2 hours every day. 1 or 2 solar panels and deep cycle storage batteries would greatly reduce my monthly bill. A few more would look after the needs of an electric vehicle. This all takes some investment of time and money, but with all that energy potential, it is a shame not to do so. And eventually, all the world enthusiasm adds up to a lot of pressure on the oil companies. Just as all that end-user gas filling put those same companies in the position they hold today. We should give the last word here to the late Jack Rickard. He said, quote, "We didn't leave the Stone Age because we ran out of stone. Indeed, we did it because there was something better to move on to, and so it will be with our energy."